Okay, so welcome back, guys. In this video, we will discuss. Ooh, okay, today we will discuss some questions on DP further, right? Okay, so these are the questions, I think. BPO subsequences, I think I was doing right. So yeah, let's do some things. Subset sum. Okay, let's do directly. I think okay. Yesterday it was 4 only. It changed again. Now I'm just doing it. Something. Rest of this. True, false, Yes. Okay guys, we yesterday I think done this question. Alright, yeah. So we will not look into this. Now we will do this question. So let's see what is this question says. Question says like we have given an array of nums and an integer k. We have to return true if there exist subsequences such that the sum of all elements in the subsequence is equal to k or else false. Alright. So okay. So this is the question, guys. Alright, so let's start this. Right. Right. This is the question. If you know, you know. Right. So we have some array. Let's say this is our array 1, 2, 3, 4, 5. Right. We have to take this k is equal to it. So we have to check like if we can take the subsequence from this, which have sum of 8 or not. So let's say we are here. What we can first we will try to write the recursive solution for this. We will try like we are at index this. What is the choice for us? We can take it or don't take it. Take or don't take, right? Then we go here like that, and take, don't take we do, and add that. If the target goes for 0 or equal to this, then okay. So we go from here to here, all right. From 1 to this, all right. We have this target, all right. So let's write the recursive solution for this guy first, right? Okay. So recursive solution for this will be like alright, we have target as k and nums as okay. So first we need to print how many elements are there. So we need this nums dot size for this, right? Then after it, what we need? We need a loop or a function. Okay. So we need a function, right? Which will return true or false, which will take this as this, right? Which will take index I and integer target. Then if target is equal to 0, we will return true because we can achieve this by not selecting any element, right? Right. So target return true. Otherwise, one is bool take is equal to f of what? If we are taking of one integer, then we are passing nums, then I plus 1 and target minus nums I, right? This will condition will only valid if nums of I is equal to target, right guys? And bool not take, we can refuse to take this also. Nums I plus 1, in that case target will remain same. We are not taking this, and after all we will return take or not take, right? One more thing, if I is greater than equal to n, or we can say nums dot size return, in that case, because we didn't achieve the solution, and our this is we have exhausted all the arrays, return false in that case, right? Okay, I think we should return f of nums 0 and k. I think this should work, guys. let's try it. Right. Okay. I have to log in. So I logged in, guys, in this. I don't know what is the hell you're doing. So log in, right? Is it logged? The question is logged, right? Or what? I don't know. Payday sale is live. I'm not interested in the sales. Okay. Alright, some problem has happened. Oh, what is the problem here, guys? We are taking compilation error. Why? Let's see. Nums I. Tag was not declared in the scope. Okay, so let's do this thing. We got it in the scope, right? Okay. Right. Accepted. Right. So both test cases accepted. We can do this, guys, by DP also. Right. Okay, so we will not do here the DP, we will do here the DP because we have alternate question here on GFG. So let's see. Given an array ERR target is there, check whether there is a subsequence such that sum of polynomial subsequence will be. So we are here. So what? Let's drive this DP. So we can have elements. Here we can have the sum here, right? Sum 0, 1, k, element 1, with element we can achieve it or not, with element 2 element achieve or not, like this, right? We can have like this. So take, don't take, we will do that also. But okay, we will define the DP and then okay. We will have this DP of vector of bool, right? M comma vector of bool, M comma I think k comma false. I think it is k plus 1 because we are going from 0 to k plus k. K plus 1 and also I think we need this k plus 1. What is m here and m is a size here of array, size like this, right? After it, like what we have the function here. The function we will pass the array. Then index I which is 0 and k dp logic plus, right? We can return this function from here only. Then after it we will define our function. We have a vector of int error. Then we have int I, we have int target, we have a vector for bool, nice, like this. Okay. If I is greater than equal to nums dot size, we have to return false in this case, right? And if target is equal to 0, then return nums element of I, target, we can say return true. Okay. And we go from here to there, like if we will take here false if target is equal to nums of I, then only we can take it into f of I plus y, target minus nums of I, right? Then dt. Okay. Then after it, we have we will take f of your comma I plus 1 comma target and dt, and then after that dt of I comma target equal to take or take, right? Dynammic. Okay, so what is the problem? Nums was not declared in the scope. Okay. Okay, nums is not there, it is ARR. So we can get nums. Take was okay, where? So we are using both here. Okay. Is there any? I use wow. Is there anything else? This one submit. Let's submit it. Okay, it's a TLE is giving, right? Is there an infinite loop or what? What is that? Oh, your size. Okay. Let's do this. These are runtime error. TLE it is given. It's giving TLE in case of okay. So it needed 1D DP, right? It needs only 1D DP. So I will be back. I have an order, guys. I will be back in a minute. I need 1D DP only for this. So okay. Or it doesn't it need tabulation or what? I think DP should have worked here, right? Okay. If DP of I comma target is not equal to false, first return true from here, symbol in here, sunlight, but now we are moving ahead, guys. Okay, review by comma target true. Let me see, guys. Let me check how it will go. 39. Okay. So let's go for the group. What is the problem here? that guys I'll back because of something I was not here. Okay, so what was I was doing wrong in this? Let me see. I get some coke, guys. Just in case. So the off by one Chris. What is this? There is some banana first. Now by one Chris. If this here return false. Okay, so our part work right. So okay, so our initialization I think is wrong, right? Our DP initialization is wrong. We have to do this as mentioned. Okay, and take is false. This is right. Okay. Okay. Okay, guys, right? So export and right. Alright, this was okay, right. Now I get it, guys. Okay. Because this was the integer array, and it should not give DAD. Right. Okay. This one. Int. Greater than equal to. We can do this also. This one. Like this. I think it should work now. What? Very private, if you go public. Okay, what is this? Alright. Whatever. Wrong answer. Alright. Oh, this was not what happened in this? Okay, yeah, I was thinking about this also. That will be really false. Okay, let me do my work now. Because we are not checking this so it's done. So we can further optimize it. I think because of the tabulation, right? So this was the DB here. What we are doing? We have to take tools and 0 less than 10 plus and 4 0 like this. Okay, so like that, and what we are doing, if sum is 0, right? If a is equal to 0, then we have validity of I comma j equal to true, always, right? And if we have 0 element, right, then what we have, and we have also continue running it. We don't go further. Continue, right? But if let's say we have only we have target, but we are okay. We are not this. Okay. Now, what we can do? We either we can take it, right? Df of I comma j is equal to one case is take. Okay guys, so one thing we have to do is, let's say, listen, what we have to do. Let's take this example. Right, what we have, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and we have 2, 1, 2, 3, 4, 5, 6, 7, 8. When this is 0, then this true, all is true, right? All is true. Now, when I am here, what I will do? If this j, let j is greater than equal to area of I, right? Only in that case we take it, I will take it, and what I will do, I will take this and area of j minus dp of j minus area of I. Let's, I will take this, right? According to this. Okay. J minus of I. I guess only if j greater than equal to I. Right? Only that is. Okay. Now at the end it will return dp of minus 1 comma k. What are you going to do? Now we can take this bool hash. take case. So we should have also not take case, right? So where is the not take case? Not take case is what I remember. What? What happened, right? What's happening? Rules that you can. What I'm doing now? What you doing? True, true, is true. Continue. Oh, it's good. What is the problem? Hmm? Hmm. Hmm. Or did you also? Okay. Alright. So I comma this. And this is I minus 1 comma j. That was the problem, guys. My bad. Before here. 41 line. Alright. Oh. Yeah. Because I minus 1 is here, right? Or first row is like that. So what are we doing? Okay, so let's take equal to cos and like this. Now take equal to cos before I watch. What happened? Take it false, if the J is take it like that. Let's define here, we do this. Okay, now it's written, but it will not pass, I think, both the people. Yeah, because it will give wrong answer. Because we are using the same thing multiple times. So, because in this case, let's do this, guys. Okay. So what we are doing, let's say this is true and we are here, it is true, right? Then it was here 2 minus 1, true, 3 minus 1, true, all are true, right? And now we are here on 2. It is not there. Then what we do, I minus 1 comma j, we do get true from here. Okay, because we can get this from here, from these two elements. Say true it is getting. I think it should have worked, guys. This also should have worked. We will not do the I minus 1 comma j. 0. So 4, right? What is the problem with this? I think it should not have any problem, but let's see what is the problem. Initially, I will share the root unbounded air. Okay. I have to imagine you are area 2, the target is 4. You check the code J is equal to 2. Check the target 2, target ratio is equal to true. Okay. Okay, so I have to go for I minus 1, right? Okay. Like that, okay. Okay, so if you are okay, or base case is 1. Which one is this? I equal to 0. Target is 0, then all true, right? You already did that. Base is to 4 by first item, I equal to 0. Can only 4 by non-zero sum. The sum increase its own value. Right, so we are 0 is less than equal to 3. And then dp of 0, comma, 0th item, row, that column of that value is true. Okay. Alright, we are already doing that. Right. Okay. Right, guys. Now I understand what is the problem we had. So this was correct. This visualization is also correct. I think just we need what? We need one visualization like what 0th item. Right? For int I is equal to J is equal to zero. What? What was that? No. Okay. If condition. It is not for condition. It is if condition. If first element less than equal to the target, then only what we do? dp of your first element row and the element is equal to true, just like that, and we go for 1 here. I think it should work now. No. Okay. Okay, so we have to take this not take pen, we have to okay, we can okay. One the original thing we relay should be left. Okay, now it's also problem here somehow. We can go down here. Right. Equal to 0, dp of I comma j is true and continue after that. Take false. Take is like that. Take is false. my problem, guys. No, take I am doing right thing, take I am doing right thing. Right, take all. Okay, this is also thing like, okay. Is this the problem? I don't think this is the problem here. This is not a problem, guys. No, this is not the problem at all. So this is the problem, I think. I have to like this. I have to base case initialize the base case correctly. Okay. Right. I have to do this. Do this and I have to integrate this. One like this. Then I will remove it. I think it should work now. Not working. TL is there. What is this, guys? J will take. Let me see. What is the problem here? What is the response here? Both solution AC accepted AC. Origin code is correct. Correctly, alright. Okay, we can space optimize it. Okay. So it is saying like okay. So this is asking for more optimized version. I will give it just a minute. My switchboard is off right now. So now we have to optimize it more. How we can optimize it? We only need these two previous, right? So what we can do is we already need this 1DDP only. These two for I minus 1. Of size how much? Like this. We need we have for previous, we have for current, right? We have two DPs. Alright, then what we can do? For 0. Okay, so previous, right? Previous of is true, like this. We can do this, and for this, because for each row at 0, we have to do this. Okay. All right. For both current, right? Here we have to do this, I think, every time. Okay. Like this we can take for we are going for previous only, right? Previous and previous. Current. I define current like this. Then previous equal to current. Okay. Previous. I think it should work now. No. Previous will go like this. What happened? 0 error 0. What happened? What is the problem? Alright. It is true like this only. Okay. Okay. We can alright. Like that. Today where is it? Is there any other? Okay. Alright. What is the problem now, bro? What's happening, guys? this is optimized version from me. What is the problem in this? Oh, okay. Hmm. Hmm. Okay. And this. Still time limit executed. Why it is so low? Because it needs time optimization, not space optimization. What happened? What is the problem in this solution now? What is but it's giving clearly, bro. Okay, so what I can do? Um, so one more idea can work like. Like order of n, I think we can do. Like this is let's say we have this dp previous or anything like that. Then we are giving from here to here only like this, like that, and what we will do, like a current of J, if equal to J equal to K, J is greater than equal to I, minus minus current of J equal to current of J minus I. Can it work? Well, we don't know. Finally, 0. Whatever. Like how it is going. We only need one array. Value is this. Q to J is okay, like this only. Previous one is value. Value, okay. And this. Okay. We only need then one array which is current. We don't need previous one or whatever. Right. Zero. Okay. This. If K return to what is the period? Response is like this only. J minus, are we doing J minus or J plus plus? Right, right, which is if current of j minus a by current okay, this is what we did it. Right. It's done, guys. After that we will do this question, which is run this partition equal length, which is on lead code. Given an integer array nums, return true if you can partition the array into two subsets such that the sum of the elements in the subset are equal to false. Okay, let's do this, guys. Let me explain something to you, then we will do this question. Right, what is the question? We have given some, there is a trick, guys, right? So we will use that. Here integer array nums, we have integer array, return true if you can partition the array into two subsets, like subset 1 and subset 2, such that the sum of elements in both subsets equal or false otherwise. So if you total, let's say total is odd, right? So we can never partition that in equal partition, right? So it's false always if it is even. Though then S1 partition plus S2 partition is equal to total sum, right? So what we let's say here S1 plus S2 is total, then S1 minus S2 is equal to 0, right? Or we can say like S1 is equal to S2 also, right? So 2S1 is equal to total and S1 is equal to total by 2. So if we can find total by 2 in that array, right, then we are good to. So similarly we can do this. Means first we find the total, and the total into 0 into n number of elements by n here, instead of size, right? For int I into 0, I is less than 9, plus we are going from here. So total plus is equal to numbers of I, right? We are doing it, and after that if total mod 2 is not equal to 0, return false, right? Else into target is equal to total by 2, right? Now we have some target also. We will have some dp vector, and we can write bold also, right? dp of target plus 1, all similar to the previous one, and for int I is equal to 0 I less than n plus right, and dp of 0 is always true, right, and what are we doing? Okay, so if okay, for enter j equal to target is greater than or equal to n of I, array it is nums, right? Nums or array? Nums it is. What? Right. Nums of I, j minus minus. Then what we can do if j is because we have to make sure that if dp of we don't care, right? We don't care. dp of j is equal to dp of j minus I. If it is true, then true. If it is false, it is always only false already. So that's not the case, right? Alright. Then after this, if dp of j, we can say target, then we return true for halfway through, else in that case return dp of target, and you can do this. It is nums, okay. Okay, it's working. It's okay. Wrong answer after that. 137, 10 cases. Okay. What is this problem here? 14,9,8,432 is like how many it is? What is wrong? It should be true. Okay. 22 and 12. 34 and 6. Okay, 40 and 40 can be achieved 20. So okay, so 6 yeah, we are achieving 20. Why it is given false now? 20, can we achieve 20 from this? Okay. Put it by 2, 8 plus 1, 0, we can assume day. What is the problem is this? I think it's similar to this previous one. missing this. What is the problem? Let me see the problem also. If we do P04 J minus A minus, it's not A, it's minus C. If conditional item that was equal to 10 pounds, true. And 3 pounds item, course okay. Okay, so it's like take and not take, you have to I think it should also work because we previously discussed it, right? Yeah, so this is also working. Okay, good. Next question is this question: partition set into two subset with a minimum absolute something like that difference, right? So you are given an integer array nums for 2% integers. Let me take this one. Let me take this. Because this is the, I think this is better, right? So this is better, so we will write it down later. What is the problem? We have one problem here like this. This is the problem lies. Okay, so we are given an integer array of nums of 2 into n integers. Okay, 2 into n integers we have, and you need to partition nums into two arrays of length n to minimize the absolute difference of the sums of the arrays. So minimize the absolute difference. Okay, what is the nums to each element of the nums into one of the two. To partition nums, put each element of nums into one of the two. Okay, that's the difference. So one partition minus h partition is equal to difference, right? Okay, so 1 is equal to h2 plus d. So total is equal to s1 plus s2. Okay, s1 to s1 is equal to total plus d. s1 is equal to total plus d by 2. So d should be minimum, right? Return the minimum possible absolute difference. Okay. If this is odd, then return false. But we have to give the minimum, which is very tricky now, guys. Okay. Why is this tricky? We have an array, right? Let's say this is an array. 4, 5, 3, 8, 9, 2, like this, right? And we have to partition this with minimum difference, right? So absolute minimum is when difference is 0, right? But the difference can be 1 also, difference can be 2 also. Okay. But difference can't be greater than what? Difference can't be greater than what we can do by this. Difference can't be greater than what? Total by 2, I think. Total by 2, it can't be greater than that, right? Because we have 0, we have 1 and 9, okay? We have to take this 8. Difference is 8. So it should be maximum of all the arrays. It can't be greater than that. Okay. partition it like what? 10 total. The difference, right? Difference can be 1, 2, 4, max. Okay. S1 plus S2 is a total. S1 minus S2 is a B. And 2S1 minus total into D. So what we have to get? Minimum of 2S1 minus total. Right. But we have two partitions into equal length, right? We are partitioning it into equal length. We have set 1, we have a set 2, right? Either this element go into set 1 or go into S2. These are the two things, right? So any element can go here and here. Now, if it is going here, then difference is sum of S1 plus D minus sum of S2. Right? Then we have to minimize. And we can take it to this also. So can we use recursion? So for recursion, what we can do? We have this area of 2n, right? We are written like this. We can take this one either in 1 and either or in not. If it is S1, then S1 goes. If it is S2, then S2 goes. Right? Okay, then variable less. Okay. Then S2 is like this. Then S1 is 1, take, not take. Either it goes in S1, either it goes in S2. If it is going in S1, it will go in S2. If it is going in S1, right? So then S1 case, then S2 case. S1 minus S2 absolute. And we will find the minimum. Minimum of S1 minus S2. Okay. Alright. Alright, I think if total is odd, we can't do that. We can do that, or even will not. Okay. We will have f function function which will pass nums I 0. Alright, we will have a function ref of vector and nums, right. We will have a if I is greater equal to nums dot size, return false. Okay, so S1 case is and S1 case is like equal to if it is going in S1, so nums of I plus f of nums right comma I plus 1 right. And S2 case, if it is going on S2, total runs I plus 1. So in that case, it should not go in S1, right? We are not doing it right now. It's a hard problem also. Okay. We can take this because we don't have much time. We have to look this up. So when n is too large, brute force too small justifiable. So you know, meet in the middle of the imagine you are happening basketball team, versus over. application is more calculated only. Even though the application that you must give them minutes more related time. Only. Okay, split numbers into left and right half. Okay. Then a full valid array of size consists of k elements. Now left and right from the right. Moving from right to sum of r such that okay. Alright. I think bit masking will not work for me. Okay. What? Okay, we initialize this also. Okay. Now this bit masking will be a little bit confusing. So what we do is we mask the video for this first.
Everyone, welcome back to the channel. I hope you guys are doing extremely well. So today we will be solving DP16, and the prerequisite to this DP16 is you must have seen the DP14, which is the subset sum problem, because this problem will entirely be solved with the idea of subset sum. So let's check out the question. So the question says partition a set into two subsets such that the difference of subset sums is minimum. So you're given an array containing n non-negative integers. Again, very important, it has all non-negative integers. Your task is to partition that array into two subsets. So basically subset 1 and subset 2, such that the absolute difference between both of the subset sums is as minimal as possible. Your task is to find the minimum absolute difference considering any valid division of array elements. So let's quickly check out an example. So if we see this example 1, 2, 3, 4, let's discuss over here. So if I take this example 1, 2, 3, 4, what are the different kind of subsets that you can divide it into? So you can say one of the subsets is 1, 2, the other subsets is 3, 4, and the summation of this guy will be 3, and the summation of this guy is 7, and the absolute difference is 7 minus 3, and that's 4. So this can be one of the partitions, or you can say the other partition is 1, 3, and 2, 4. Where you say 1, 3 belong to a subset and 2, 4 belong to a subset. So the summation is 6 over here and the summation is 4. So 6 minus 4 is equal to 2. Similarly, there can be a lot of different patterns, partitions rather, not patterns. So I can be like, okay, can I divide this into something where we have 1 and 4, and the other place we have 2 and 3. So again, makes sense. And this time the summation over here will be 5, and the summation over here will be 5. So 5 minus 5 will be 0. And if you carefully see, this is the minimal difference that you can obtain by dividing them into a couple of partitions. So in short, you will be given an array. You have to take all the elements, and you put some elements in subset 1, and you put some elements in subset 2. And the subset 1, some assume it to be sum 1, and the subset 2, some assume to be sum 2. So the absolute of this is as minimal as possible. This is what the question states, right? Now, how do you solve this question? because this is something different than what we have been doing. What have we done till now? We have done a lecture 14. Yes, we have done a lecture 14. Over there, what have we discussed? We have discussed given an array. Yes, given an array, and I will give you a target, and your task is to tell me if this target, like if there is a subset, whose sum is equal to this target. So you are given an array. We have already done a problem where we have to tell, is there a subset which is equivalent to the given sum target? And if you remember, what concept did we use? We used the concept of pick and non-pick, whose sum is equal to this target. So you are given an array. We have already done a problem where we have to tell, is there a subset which is equivalent to the given some target. And if you remember, what concept did we use? We used the concept of pick and non-pick, or take or non-take, the concept that we used. So if you remember the reference, it was something like this. We wrote int index, then we wrote the target, then it was something like, if at any moment the target is achieved, we will return a true. And if the index reaches equal to 0, that means basically we started from f of n minus 1 and with the given target, if you remember well. And over here we returned array of 0 is equal to the remaining target, because if we are standing at the last element and some target is yet to be achieved, then the array of 0th index has to have that target. So remember, these were the couple of base cases. Then we wrote a non-take case where it was like, we will move to the previous index with a similar target. And similarly, we wrote a take case, which was initially false, and we can only take the array of index into our subsequence if that's lesser than equal to target, right? And over here we can only take the array of index into our subsequence if that's lesser than equal to target, right? And over here we said take will be, if we take it, it's index minus 1 and target minus array of index. So I hope you remember this recurrence. And at the end of the day we said take and non-take. So that was a quick revision. So we have done this problem, and we will be using this problem's concept only to solve the given problem. So let's forget about the current problem and let's analyze this recurrence relationship. So what did we do on this recurrence relationship? We did apply something as memoization, right? And what after memoization? After memoization, you went on to write the tabulation, if you remember. And how was the tabulation written? The tabulation clearly stated that, hey, listen, if the target is equal to 0, then over here the index can be minus 1, n minus 2, anything till 0. Basically any index, it can be any index. So we went on to write the tabulation as, firstly though we declared a dp of n of target, and then we went on to write f of index equal to 0 till n minus 1. And over here we went on to write dp of I and every index, dp of index and every target 0 as true. So this is what we wrote because it's almost equivalent to this. If target is 0, return true. So if target is 0 on any given index, you return true. That's the first base case that you wrote. And the next base case was, if index is 0, you're saying this array of 0 to be equal to target. So only at array of 0, you can just write it true, because if the target is equivalent to array of 0, then only it will be true. So if you remember, the next base case was very straightforward. You basically said dp of 0, which is this case, and then array of 0 being equivalent to target. So array of 0 being equivalent to target, which is true. But you just need to make sure, since we are declaring the dp array to be like the second dimension of a parameter target, we just need to make sure this second dimension, yes, has to be lesser than target, has to be lesser than equal to target. Just make sure this condition is written. And yeah, over here it will be of size plus 1, by the way. Perfect. So that was the tabulation. And what after that? You basically wrote a couple of loops, which was starting from 1 is to n minus 1. And then you wrote something which started from the target from 0 till, since 0 was already done, you can easily start from 1 till the target k, right? That was it. And you wrote the same thing, not take equal to dp of f of I minus 1, so dp of I minus 1 and target. And the take was initially true. Just making sure if the array of index can be taken into account, which is basically array of I here, if that's equivalent, if that's lesser than target, what you did was you said, so by the way, take will be false over here, not true. Take will be false. And you then say take will be dp of I minus 1, and you wrote target minus array of index, right? That is something which you wrote. And at the end of the day, you said dp of I target is equal to take or not take. Similar recurrence I've copy pasted. So this was the tabulation format, right? This was the tabulation format. So what will this tabulation format create? What does a dp of ij signify? That's what my question is to you. What does dp of ij signify? If we are able to figure this out, then that will help us immensely in solving the next problem. So basically, we would have taken something like this. Assume the number of elements to be 5 and the target that we have been asked is 7. Like for an example, let's assume. So can I say we will declare a dp of size 5, crosset 8. So 5 rows is what I'll declare. So let's quickly declare the 5 rows. 0, 1, 2, 3. We have declared the 5 rows. And they'll be like 0, 1, 2, 3, 4, 5, 6, 7. So I'll also declare 8 columns. So can you declare all the 8 columns? So this is how the dp table is declared. Now can you tell me, where did you find your answer at the end of the day? You said, you call the recurrence, if you remember, you call the recurrence with f of n minus 1 and target. And you said, can an array of n minus 1, like ending at n minus 1, achieve a target? Can this entire array achieve this target? That was the stuff. So you also said that the answer will be lying at dp of n minus 1 target. So what does this mean? You are saying, for this guy, if n is 5 and the target is 7, you are saying, if dp of 4, yes, if dp of 4 and the target is 8, so target is 7 over here. Because if you carefully observe, the target is 7. So you're basically saying, if this guy is equal to true, then we can have a subset sum of 7, right? So can I say, how's the dp array being filled in tabulation form? Firstly, all the base cases are filled. Like all the base cases, what are the base cases? Index equal to something and target true. So firstly, you're filling this true, 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 true. That is what you filled. Now you know that if the array is something like, let's assume the array is, so we know that the array is of 5 elements, right? So assume the array to be something as 1, 3, probably 2, 5, and 6, and the target to be 7. Okay, and the target to be 7. Let's assume this is the array that we have taken, and this is the target. So what is the first tabulation that you wrote over here? This is done. The next thing you're writing is dp of 0, array of 0 is equal to 2. So what is array of 0 over here? It is 1. So you placed a true over here. And rest, everything will get filled. Then this will be filled. Then this will be filled. Then this will be filled. Then these guys will be filled. At the end of the day, this will be filled. And whatever answer is over here, yes, if it is a true or if it is a false, whatever answer is there, you say, according to this, I get my answer. That's what you told. But in finding the target equal to 7, if you write the tabulation, you end up filling this guy, because at the index 4, like in the entire array, the target 0 can be achieved. That's very common sense, because if I do not pick up any element in the subset, the target 0 can be achieved. Similarly, whatever value will be here, I can say I can achieve the target 1 or I cannot achieve the target 2. Similarly, whatever value is here, I can say I can achieve the target 1 or I cannot. Similarly, whatever value is here, I can say I can achieve the target 2 or I cannot. Similarly, whatever value is here, I can say I can achieve the target 3 or I cannot. So can I say I can tell yes or no for every target value from 1 to 7? Can I achieve every target value from 1 to 7? I can definitely say yes or no if I write the tabulation, because the tabulation makes sure that I fill the entire here. And rest, everything will get filled. Then this will be filled. Then this will be filled. Then this will be filled. Then these guys will be filled. At the end of the day, this will be filled. And whatever answer is over here, yes, if it is a true or if it is a false, whatever answer is there, you say, according to this, I get my answer. That's what you told. But in finding the target equal to 7, if you write the tabulation, you end up filling this guy, because at the index 4, like in the entire array, the target 0 can be achieved. That's very common sense, because if I do not pick up any element in the subset, the target 0 can be achieved. Similarly, whatever value will be here, I can say I can achieve the target 1 or I cannot achieve the target 2. Similarly, whatever value is here, I can say I can achieve the target 1 or I cannot. Similarly, whatever value is here, I can say I can achieve the target 2 or I cannot. Similarly, whatever value is here, I can say I can achieve the target 3 or I cannot. So can I say I can tell yes or no for every target value from 1 to 7? Can I achieve every target value from 1 to 7? I can definitely say yes or no if I write the tabulation, because the tabulation makes sure that I fill the entire matrix, and eventually I will get to know if I can achieve 1, if I can achieve 2, if I can achieve 3, if I can achieve 4, if I can achieve 5, if I can achieve 6, if I can achieve 7. And just because the question asked 7, we picked up this guy and we said this is our answer. This is our answer, DP of 4 of 7. If the target was like, if someone comes up and gives you a different target, now you still can say without calling the tabulation again. This DP will strictly help you to tell if you can achieve a target 5 or not. So this is what I wanted to portray you. This is what tabulation signifies. For here, 3 means till only the third index. Till only the third index, a target of 4 can be achieved or not. Till only the third index. That means till here, a target of 4 can be achieved or not. This is signified by the third row. Similarly, every row is signifying something. Make sense? Okay, that does make sense, right? Okay, so we've understood this. So just keep this in your mind that as of now, from subset sum, what we have derived? From subset sum, the tabulation one, what have we derived? We can, like, if we check for a target equal to k, we can derive if every possible target, I repeat, if every possible target between 1 and k is possible or is not possible. If I'm just checking for target equal to k, the tabulation automatically will tell me for every value between 1 to k. I don't need to do any extra steps. Make sense? So with the help of this, I'll solve the next problem. Okay, so now let's come back to the DP16, which was the original problem. What did the original problem state? Divide them into a couple of subsets. Like if one subset is containing some elements, the other elements will be in the other subset. This will have a sum 1, this will have a sum 2. So both of the sums, like absolute difference, should be as minimal as possible. That was the question, right? So we were like, how can we solve this? Because we have just now learned that we can easily check if any subset of any given sum is possible in an array or not with the use of the matrix, right? So can I say, if I can just figure out S1, S2, I don't have to figure out. Think it yourself. I repeat, if I can figure out S1, I don't have to figure out S2. Why? Let's realize. If I give you an array like 3, 2, 7, okay, and if I say one of the partition contains 3, so the summation is 3. Do I need to find the other partition like 2, 7, do the summation as 9? Do I need to do that? The answer to that is no. Why? Because if I know the total sum, because the total sum over here is 12. If I know the total sum, so can I say that the summation is 3 for the first partition? The summation for the next partition will be total sum, because total sum means all the elements minus the sum of the elements that are in the partition 1. So 12 minus 3 is 9. Again, makes sense, because if the total summation is 12, which is that all the elements, if you take out 3, the remaining elements will be nothing but 12 minus 3. So you get the easy sum of S2. Can I say in this way? Can I also say if I take just 2, then it will be 2, which will be S1 will be 2, and the next partition will be 10, like the summation will be 10, because if I take 2, these guys will be in the next partition. That can make sense. So can I say what am I looking for? I'm looking for S1 minus S2 to be as minimal as possible. So if I'm looking for S1 minus S2 to be as minimal as possible, do we actually require yes? Do we actually require all the possible, like, if I can give you all the possible S1s, then your job is done. If I can give you all the possible S1s, because I can say I'll try out all partitions of S1. You're like, but Trevor, how's it gonna work? Again, it's not work. If I ask you what can be all the partitions of S1, can I say the minimal summation of S1 will be 0, when I say I don't pick up any element, when I say I do not pick up any element. Make sense? And the maximum summation will be when I say all the elements are in my partition. Okay, well, so can I say the minimal value of the partition 1 summation will be 0, when I say none of the elements are in my partition, and the maximum value that I can get is 12, when I say all the values are in my partition. So I know the minimal value is 0 and the maximal value is 12. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I ask you, I know the S1 will be in this range, but I need to determine which are the valid S1s, because everyone cannot be S1. All the partitions are not possible. So you'll be like, okay, we remember DP14. Just now I taught you. The last row will tell you if 0 is possible, if 1 is possible, if 2 is possible, if 3 is possible, if 4 is possible, if 5 is possible, if 6 is possible, if 7 is possible. So can I say, I know one thing. 12 is possible, because I will take all the elements. So if I call the tabulation method for this, which is size 3 and 12, if I call the tabulation for DP14, the DP14's last row, yes, the DP14's last row will tell me if 0 is possible, 1 is possible, till 12. In that case, it will. So now what I can say is, okay, let's check if 0 is possible, and it will tell me yes, 0 is possible. Let's check if 1 is possible, it will tell me no. Let's check if 2 is possible, it will tell me yes. Why? Yes, 2 is possible. 3 is possible, yes. 4 is possible, no. 5 is possible, yes, because 3, 2. 6 is possible, no. 7 is possible, yes. 8 is possible, no. 9 is possible, because 7, 2. 10 is possible, yes, because 7, 3. 11 is possible, I don't see any way I can make 11, can I? 7, 3 will be 10, no, I can. 12 is possible. So I figured out what values are possible, and this can easily be done with the help of the last row that has been generated in this DP array, if I call the tabulation method of subset sum. So can I say that 0 is possible, 4 is possible, 6 is possible, 8 is possible, 11 is possible. So these are the valid S1s, which are possible. These are the partitions that are possible for S1. So can I find the corresponding S2? Just think inside your brain. Can I find the corresponding S2? And the answer to that will be yes. This will be 12, right? This will be 10, right? This will be 9. This will be 5, 7. This will be 5. This will be 3. This will be 2. This will be 0. So I see that I got, for every S1, I got the corresponding S2. For every S1, I got the corresponding S2. Can I say the difference, the absolute difference over here is 12. Absolute difference over here is 8, 6, 2, 2, 6, 8, 12. What do I need? The minimal. And what's the minimal that I see? It's 2. So that's my answer. Using subset sum, I did it super duper easily. I don't find any problem in this, and this is definitely going to be my answer. Now we can probably write it. Assume you have called the subset sum problem, the DP has been generated. So it's basically you call the DP for n and summation plus 1, and you can say this is the total summation, because that's the maximum value you can. Call the subset sum code, okay? I'll show you in the code. Call the subset sum code. So the DP of the last row will be right there. So now you can say that I know from 0 till the total sum it is possible. And assume you can keep the mini as 1 in 9. Can I say if DP of the last row and this target I is possible, then what will be S1? I know S1, like if I just write it, S1 will be I, S2 will be total sum minus I, correct? So thereby I can say minimal, because I need the minimal absolute difference, mini comma, absolute of S2 minus S1. So that's how you can easily write this. So if you try to write this in terms of formula, it's going to be total sum minus 2 into I, so you can also write that. But yeah, in this way, if it is possible, if this summation is possible, you directly check on the last row. You take S1, you take S2, and you get the minimal possible value. Now can we optimize this? Yes. If you carefully observe, 0, 12, 12, 0, 2, 10, 10, 2, 3, 9, 9, 3, 5, 7, 5, 7. So basically what happens is the subsets. So you had 3, 2, 7, right? So first time it might have taken 3 in the subset, in the partition 1. In the next time the partition 1 might have 2. The next time the partition 1 might have 7. Going across, there will be a moment, the partition 2 will be having 3. partition 2 will be having 2, the partition 3 will be having 7. Like it can also have single elements. So do we need to check? Because we're just checking for absolute difference. So thereby I can say if I check for half of the sum, then also we should be good enough. Because I know whatever partition 1 looks like, if I make the partition 2 look like the same, the answer is not going to vary so much. If you carefully observe, we took a summation 0. Going across, we set the partition 2 have summation 0. We took a summation. So do we need to check? Because we're just checking for absolute difference. So thereby I can say if I check for half of the sum, then also we should be good enough. Because I know whatever partition 1 looks like, if I make the partition 2 look like the same, the answer is not going to vary so much. If you carefully observe, we took a summation 0. Going across, we set the partition 2 have summation 0. We took a summation 2. Going across, we set the partition 2 to have summation 2. So it doesn't really make sense. That's why if you still do to the half, you get your possible answer. So that's how we can easily solve this problem. I'm trying to show you the code so that it gets much more clear to you. So by the way, this was the lecture 14 subset sum equal to, and this was the entire code. Okay. So what we will do is let's check out over here what's given. Array and n. So at first let's keep a total sum. Okay, let's just keep a total sum as 0, and probably we can just sum it up by going to 0 till n, which is I plus plus, and I can say total sum is equal to array of I. That's something which we will do, right? Right after this, what you will do is you just call this guy. Nothing else. Just call this. Just copy paste. Because this is a subset sum.
Alright guys, so that was the solution. Let me code it myself, right? With tabulation method also. So 10 is nums dot with size, right? Sum is zero and y is like n plus, right? Then sum equal to nums of I here, and after that what we can do, so we have the sum, and target we can take like get by 2, sum by 2, right? And we define a DP array of 2D of integers, DP of n comma vector of n comma what? It's target plus 1, because we want okay, so we can so it's like Boolean array, right? Bool, let's see, we have also bool true false and only false, right? And after it, for and equal to 0, I less than n plus plus, and we have for into g is equal to 0, g is less than equal to target plus that. After it we can initialize it like if we have equal to 0, then we have target 0, right? So we can initialize this plus dp of I comma 0 is equal to true here, right? And also if if for first element a array of 0 which is less than equal to target, then dp of 0 equal to true, right? Then we can go from 1 to here, right? Then we can go for like if okay, so dp of I comma j is equal to dp of I minus 1 comma j minus 1, right? Not j minus 1, j minus of I or p of I minus 1 comma j. This is case of take and not take. And after this, what we can do, we have int many which is 189, and after that for 0 less than equal to target I plus plus, if dp of n minus 1 and I, then what we will take, int diff is equal to target we can get from I, okay? So sum, yes, sum minus I, it is the target, right? This was the difference, and many is equal to many of many comma diff okay, so S2 that so minus S2 S2 minus I. Alright. I think this will be the solution for this.
So this is the n into k plus 1 vector. So instead of k, k will be, the target over here is initially total sum, because that's the maximum that's possible. And yeah, there was edge case that was missing over here. The array of 0 has to be lesser than equal to the target that you're looking for. Otherwise, it will overflow. So just make sure you do this, the array of 0. So I can say the entire vector is generated. And over here, can I see the array of, or rather, the dp of n minus 1 and the entire column from 0 to the total sum will tell you. That's all I can. So I know I need the minimal. So minimal can be 189. And I know I can start the target, like I can start the S1 rather from 0. And the S1 can go on till total sum by 2, that we have already proved that. And S1 plus plus. So can I say this? If DP of the last row, in the last row, if S1 is true, then only it's possible. Then only it will be possible. And if it is possible, can I say mini will be min of mini comma total sum minus S1 is what your S2 will be minus of S1 and an absolute of the entire stuff. Yes, an absolute of the entire stuff. At the end of the day, can I say I will return the mini? So if I just write this and let's run this off.
Let's try to run this for myself also. Why comparison? It's all non-zero. We should really look at this. So 0. Okay, so if G greater than equal to means 0 means not equal. True. Okay. So it can have negative numbers also. Wow.
Let's see if it's running fine. It does run. So let's quickly submit this off. So you see.
runtime is real video. Wait guys. Because we are hitting the negative bound, so we have to modify this for that also. So we can shift the index by max minimum in the array to the right. Okay. And okay. Okay. 0 by 2 0. Okay, so guys, I have to let's see what can work it out or not. Can it work? Yeah, it's working like this. So it will, I will understand this. Okay, I can understand this now also. What is this problem? Like left sum, right sum, we have initialized these two arrays, and we have left sums and right sums also, like this. Okay. Now mask, what is this? Generate all subset sum for both halves using bit masking. Okay. So how can we do that? Mask is equal to 0, mask is less than n by 2, right? Plus mask. Okay. So we are going for n by 2 here. This is n by 2. 1 is okay. So it's 2 to power n, guys. I think it's 2 to power n. Because 1 is right left shifting to n times offset. Mask is less than 2 to power n plus mask. Okay, so I can copy this from here and I can paste it here also. Right. And paste it here like this. Alright, this is the solution. So what is the, it has these values, and left solution generate all subsets of both our using bit mask. Mask is equal to 0, mask is you have to change this page to plain. Okay, it's clear now. So here what happened? Okay, let's color, make this colorful a little bit. This is 2 to the power n plus mask size L left sum right sum. Okay, now int I equal to 0 to n, so this is 2 to the power n, this is 2 to the n. If the ith bit is set, include the ith element. Okay, if mask and mask is what, 0 is still, 1 is I times, okay, 0 size plus plus, let's I have to, I think, search this video somewhere, I think. In the middle DP vertical subset some difference like this. Okay. Minimum subset some difference. I think it's
होगी, ये कभी नेगेटिव नहीं होगी। क्यों नहीं नेगेटिव होगी? क्योंकि मैंने S1 को कभी हाफ वे से इधर लिया ही नहीं, तो मेरे को केवल इसके हाफ में देखना है एरे में एग्जिस्ट करता है कि नहीं, ये वाला ब्लॉक बताएगा, राइट। जहाँ
Hello guys, welcome back to TechDose, and in this video we will see the meet in there. I hope now you must have got the exact goal which made exceeded error. The goal for this problem is to solve it within 1 second, and therefore the total operation. So this 0 here means that I have not included any item from. Now a better approach will be to take basis 2, because we are
then my n will be 2, because it is saying that it 4 is not there, so okay, simply skip, go on to next,
this is the video.
go on to next. Here the sum is 2,